All right, guys, today we're going to go ahead and talk about the angle measures in convex polygons. So we're going to start off talking about the difference between interior and exterior angles. The interior angles of a polygon are the inner angle. So they're the inner angle where two sides meet. Okay, so when we're looking at the inner angles, we're talking about A, B, and C are those inner angles, okay? And then our exterior angles are the angle between the side of the polygon so between the side and the extended adjacent side. Extended adjacent side. So if we take an angle, so here we have a side, and the adjacent side is right here. And if we extend that, the angle that we're looking at, D right here, this is your exterior angle. Okay, we have another one here and another one here. So D, E, and F are exterior angles. A, B, and C would be interior angles. Okay? So, something that you would have learned previously is that the sum of the interior angles of a triangle equal 180 degrees. And so we're going to use that. So what that says is that if you take A, B, and C, these three angles, add them up, they're always going to equal 180. So we're going to use that a lot today. We also need one more definition, which is a diagonal. And this is a line segment. So a line segment connecting non-adjacent vertices. Remember, vertices are just the corners of your polygon. Okay? So, what we're going to do here is look for the sum of the interior angles of these polygons. And we're going to take a triangle first. Okay, so we're going to talk about a triangle first. And if we look up here, we have a triangle. Look at that. How convenient. So we have a triangle that has three sides, and there's only one triangle here. And we already know that the interior angles of a triangle are 180 degrees. So if we take the sum of all of those angles, that's going to be 180. Okay, triangles are pretty easy. All right, let's look at something slightly more complex, a quadrilateral. So if we take a quadrilateral that has four sides, now we're going to draw a diagonal here, and we can see that there are two triangles. So we already know that the interior angles of a triangle are 180 degrees, and if we have two triangles here, then we're going to have 360 degrees for the sum of all of the interior angles. All right, let's keep looking. We're going to go pentagon now. So a pentagon has five sides, and when we draw these diagonals in, we're going to have three sides. Three triangles, five sides, three triangles. We already know that each triangle has 180 degrees. And so the sum of all of those triangles together is going to be 540. All right, we've got one more. You might already notice the pattern. So we have a hexagon, which has six sides. So we're going to take one of these vertices, and we're going to draw the diagonals. And we can see that there are now 4 triangles. Triangles always add up to 180. So now we're going to see that we have 4 triangles, each one's 180, so we're going to have 720 degrees in total. So at this point, if you haven't figured out the pattern, you could pause the video, try and figure it out for yourself. Okay, if you paused it, great. If you didn't, well, here you go. We're going to give you the pattern anyway. So the sum of the interior measures of a convex polygon with n sides, here's the equation, n minus 2 times 180. So what we're doing is we're taking the number of sides, subtracting 2, and then multiplying it times 180. So as an example, n is 15, so we're going to go n minus 2 times 180. N is 15 minus 2 times 180. So we have 13 times 180, which we will punch into a calculator and gives us 2,340 degrees. So if we take all of the angles, all of these interior angles, and we're to add them up, we would get 2,340 degrees. Okay? Excuse me. So with a regular convex polygon, all of the interior angles are congruent, okay? So what that means is if we have a regular polygon, meaning all of the sides and all of the angles are the same, then the interior angles are all going to be congruent, and so we can represent that by an x because they're all going to be the same. So let's look at what a regular triangle would do then. So we already know n minus 2 times 180 works for us. So we'd go 3 minus 2 times 180. Well, 3 minus 2 is 1, so 1 times 180. That's just 180. Kind of knew that already, but going through the process. So now each angle, and there are 3 of them, when we take those 3 angles, multiply them, or add them together, right? X plus x plus x, that's the same as 3x, needs to equal 180 degrees. Okay, because we have, so let's just draw a picture. That way I'm not losing anybody. X plus x plus x. So if we take those, add them, x plus x plus x is the same as 3x. Okay, so just in case I lost anybody there for a second. So I have 3x equals 180 degrees. Divide both sides by 3, and I get x equals 60. So what that means is that the interior angle for a regular triangle is going to be 60 degrees. And what we just did is going to work no matter what polygon we have. As long as it's a regular polygon, we can come in here and do n minus 2 times 180. That gives us the interior angles. And we just divide that by n, and that's going to give us the individual angle for a regular polygon. Okay. One last piece that we're going to talk about, which is the sum of the exterior angles. Okay. So all exterior angles of any polygon, so this works no matter what size polygon we have, are going to add up to 360 degrees. All right, so let's see what this looks like. If I take a triangle, and now I extend the sides, so I extend them so that I can have exterior angles. So I have angle 1, angle 2, and angle 3. Those are the exterior angles. If I take the measure of angle 1 and I add it to the measure of angle 2 and the measure of angle 3, this is going to equal 360 degrees. Okay, so that works for triangles, but it would also work for a quadrilateral. So let's take a quadrilateral here. Remember, quadrilateral is just 4-sided shape. Again, extend those sides so that we have exterior angles. Okay, extend those sides. And now I have angle 1, 2, 3, and 4. And what I can do is take the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4, and that's going to equal 360 degrees. Again, it doesn't matter what type of polygon you have. When we add up the exterior angles, it's always going to equal 360 degrees. All right, that covers us for notes today. I'll see you soon.